Hi, everyone. I am so happy you've stuck with us and you are back for one more review for the APCS Principals exam. I'm Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois. I'm sporting my Bulldog Blue Pride tonight, and I'm really, really happy to be here and to be with you so we can review a little more about APCS Principals. What are we going to learn today? Well, in this video, we're going to cover strings, calling and developing procedures, and libraries to develop algorithms and interpret code segments. We will also explore simulations, algorithmic efficiency, and undecidable problems. Sounds almost spooky. Our agenda is we're going to discuss the topics and skills that will be covered. As always, I'm going to review some vocab, and then we're also going to look at the exam reference sheet for the specific topics that we're covering today. And then we'll look at an example multiple choice question. Don't worry, I will give you a little more plug for Create PT as well. Specifically, the topics we're going to cover from Big Idea 3, once again, are 3.4 strings, 3.12 calling procedures, 3.13 developing procedures, 3.14 libraries, 3.16 simulations, 3.17 algorithmic efficiency, and 3.18 undecidable problems. Some of the skills that will be covered include investigating the situation, context, or task, evaluating solution options, using abstraction to manage complexity in a program, and determining the result of code segments. Now, once again, I want to make sure we're clear. These are only seven out of the 18 topics. So when I say that 7 out of 18, that means we still have other topics from Big Idea 3. But all of Big Idea 3 will cover approximately 30 to 35% of the multiple choice questions in the AP exam. These questions could be single select, meaning you just have one answer, but they also could show up in the multi-select section, which is choose two. So there would be two answers in those cases. We do not have any that have more than two. And the ones that say select two clearly say select two. So don't assume you have to watch out for that or that it's a trick. At the end, we're going to talk a little bit more about the format of the exam, just to make sure that you know exactly what to expect. So we're going to review. And of course, I know you'll be surprised. We're going to do some vocabulary. All right. String concatenation. Concatenation is a long word that basically means just joining two things together. Specifically, we'll put strings end to end. So if I have the string cat and I concatenate dog to cat, it would be cat dog. A substring is just part of an existing string. So if I have the string computer, put PUT is a substring of computer because PUT is 3 of the characters of the string in a row that happen to be part of the word or part of the string computer. A procedure is a named group of instructions that may have parameters and or return values. And some programming languages, you might have called these things methods or functions as well. So procedures, methods, functions, they all basically in terms of programming mean pretty much the same thing. We're going to refer to them with the pseudocode as procedures. Parameters are input variables of a procedure. So sometimes we are going to send values to the procedure to somehow do something inside the procedure. The values that we send to the procedure are called parameters. Arguments specify the values of the parameters when the procedure is called. So when we talk about the variables are the parameters. The values of the parameters are arguments. So if I send X to my parameter, or X to my procedure, I apologize. X goes to the procedure, X is the parameter. If I store the value 5 into X, 5 is the argument. Procedural abstraction provides a name for a process and allows a procedure to be used only knowing what it does, but not how it does it. So, for instance, maybe in some of your programming languages, you might have used an abstraction for print. You might have been able to just say print hello or display hello. Well, there's a lot going on behind the scenes to make hello display on the screen or print out somewhere. We really don't care what all of those details are. We just know that we can use that abstraction, print or display, and it will work for us. Okay, a little more here. We have the subdivision of a computer program into separate subprograms is called modularity. So that could happen in a variety of ways. That could include things like procedures. A software library contains procedures that may be used in creating new programs. These are procedures that someone else created and put into a library. We can almost like check it out, like we can check out a book and we can use those procedures in our programs. An application program interface or API. APIs are specifications for how the procedures in a library behave and how they can be used. So they're kind of like our manual for the procedures. A simulation is a representation that uses varying sets of values to reflect the changing state of a phenomenon. They often mimic real world events to draw inferences without the constraints of the real world. So we want to try to run a simulation to maybe figure out how something might work before we actually do the real thing. That might be to save money. It might be because we want to be safer and figure out what some of the potential downsides or pitfalls might be, or any of the dangerous things that could happen before we actually run it in real life. A problem, I'm sure you're thinking, I know what a problem is, but specifically, we want to refer to it as a general description of a task that can or maybe cannot be solved algorithmically. A decision problem is a special problem. This is one that only has a yes or no answer. There's no in between. Yes or no. An optimization problem is one where we try to find the best solution among many. So I think about that in terms of sometimes I'm trying to get directions from work to home. And yes, I know how to get there, but what's the best route to take so I can get there as soon as possible? I want to optimize my route. Efficiency is an estimation of the amount of computational resources used by an algorithm. This can be done through formal or mathematical reasoning, but an informal estimation can be done by determining the number of times a statement of group of statements executes. All right. So sometimes we just count it, and that's more of an informal estimation, but it still gives us an idea of how efficient our pseudocode, our algorithm, or our program is. When we talk about how long it takes an algorithm to run, we say it's a reasonable amount of time if there is a polynomial efficiency or slower. So a constant, meaning it's always the same, or linear, meaning it just goes up at a constant rate in terms of x, or a square, like x squared, or even a cubic. But as soon as it becomes exponential or factorial, the efficiencies then are an unreasonable amount of time. We're going to do a problem with this one a little later. Okay, a few more. I promise we're almost done with our vocab. A heuristic is an approach to a problem that produces a solution that's not guaranteed to be optimal, but may be used when techniques that are guaranteed to always find an optimal solution are impractical. The reality is, when I try to find the optimal route in terms of speed to get home, well, there's too many things that can affect it. If a car breaks down, if there's an accident or anything like that, that might slow down the traffic that can't be always anticipated. So sometimes what we do is we use a heuristic algorithm. It's not guaranteed to always be optimal, but it's usually going to do a pretty good job most of the time. A decidable problem is a decision problem for which an algorithm can be written to produce a correct output for all inputs. And an undecidable problem is one for which no algorithm can be constructed that is always capable of providing a correct yes or no answer. Okay, I know there's a lot there, but go back and review it as time permits. But for now, let's move on to our favorite thing, the exam reference sheet. So once again, if you don't have a copy of the reference sheet in front of you and you would like to access one, you can go to this Google folder, and inside of it is a PDF of the exam reference sheet. This format that you will see there is exactly what you're going to see when you are given the hard copy on the exam day. So you will get this exact exam reference sheet. So if you want to pause the video and grab a copy of it, whether you print it or just open it up in another link, absolutely fine. Come back when you're ready. All righty, here we go. So we're going to look at some different parts of the reference sheet today. Today, one of the things I really want to focus on is procedures. So just like before, remember, we could have a text version of the question, of pseudocode in our question, or we could have a block version. They don't look that different, but there is differences, so I just want you to be familiar. If you're really used to only block programming and you see it as text programming, you can see which one it is, and then maybe you can kind of in your head or even sketch out, because you're allowed to write on the test what it looks like in block if that makes it a little easier for you. And same thing the other way. If it's given to you in block, you can look at the block version here and then kind of see, well, oh, that's what I'm used to seeing in text. So in the text, we'll have the word procedure all uppercase. And then this next part here is the name of the procedure. So this will be different. It could be find min, it could be calculate average, whatever we might want to do. Hopefully the name is something that gives us a clue of what's going on in that procedure. And then we may or may not have a list of parameters inside. If there's no parameters with the text, you'll see empty parentheses. You might just have one parameter, one variable, or you might have multiple parameters. Whatever is inside the curly braces will be the statements, the block of statements that are a part that execute when this procedure is called. You'll notice in the text version, it looks similar, all uppercase procedure. Then we have the name, and then the parameters, if any, will be in a rectangle. And then the block of statements is just in this inner rectangle. Let's take a quick peek at an example. So I have a procedure called find min, and I send it a parameter called scores. I start my new variable min and assign it the value of whatever's at the first position in scores. So scores must be a list. And now I'm going to go through this list for each num in scores, because this is one of the for loops we can use to go through a list. Feel free to look at different parts of the exam reference sheet. You'll see in the lists part, there is this for each loop. So it's going to get every number in scores, and one at a time, it'll compare it to min. If the number we get from scores is smaller than the current value of min, min will get updated to the smallest value. So when the for loop is finished executing, we will display min, which hopefully should then be the smallest number in scores. So outside of the procedure, I might have this code over here. So scores is set to a list of integer values. I call the procedure find min scores. So I'm calling the procedure find min and I send it scores as the parameter. These numbers, this list is what is getting sent here. So when the list is sent here, it is going to go through the list. Min starts at 80 and then it checks. Is 95 smaller? Nope. Is 90 smaller? Nope. Is 108 smaller? Mm-mm. Is 72 smaller? Yes. So min will now be 72. Is 93 smaller than 72? Nope. And there's nothing else to check. So the for loop ends and we display min. So what happens? Well, 72 is displayed. When the procedure ends, we're going to go back over here, find min completed its execution. So now we go to the next line in the code and display finished. So the 72 was displayed from this call inside the procedure. After the procedure was completed, the display finished caused this line finished to be output. All right, if you need some time to digest that, feel free to pause and look back at it a little bit more. Right now, I'm going to look at procedures and return. So we're still in a procedure. The difference is sometimes we're going to return a value. In text, we'll see the procedure looks exactly the same, but somewhere inside that procedure, you'll see the word return in uppercase, and in parentheses, some kind of expression or value. And that value will be sent back to whoever or whatever called it. In the block version, it looks the same, but you'll see this return as one of the statements inside the inner rectangle. So in text version, it's just all uppercase return with the expression in parentheses. In block version, it's all uppercase return with the expression in a rectangle. Don't worry, we're going to look at an example right now. So this is going to look similar to what we just did. We are going to have a list of numbers of integers that are stored in scores. We're going to call the find min procedure for scores. And when the procedure is done, we're going to display finished. Now the difference is in the last example, I said display min. I changed this to now return min. So everything else in this procedure is the same. But instead of displaying min, I'm returning it. So I do find min scores. It goes through here, min becomes 72, and I return it. So it's sending it back to where it was called. So when I run this code, the only thing that was output was finished. Just returning a value does not output it or display it or print it. One way to do this is to make the find min scores call and say, take whatever's returned and store it in this variable winner. So now we have our list of integers. We send that list to find min procedure. It figures out that min is 72. It returns the 72 and stores it in winner. Now I can display winner and I can display finished. Now there's more than one way to do this, but that is one way to make sure. I really want to emphasize though, return is not the same as display. If I display, it will output to the screen. If I return, it'll send the value to be stored somewhere. And the plus side is if I wanted to use that value at another point later in the program, I would have that stored in a variable. It just depends what you want to do and what the purpose is of your procedure and of your overall code. So those are the only things we're going to go over on the reference sheet in this video. I know it's pretty fast today. I'm kind of surprised myself. But of course, we want to practice a little bit. So we're going to look at some string procedures. Now, string procedures can come up on the exam. They might come up on the exam. If they do, you're going to be given some type of explanation of what they do. These are not on your exam reference sheet. So when you are given a table or some kind of explanation with the procedure and what it does, don't go looking for that procedure on the reference sheet. That means it's not there. This is something in addition to what's on the reference sheet. So let's take a look. Consider the procedures for string manipulation. Concat str1, str2. What this does is it returns a single string consisting of str1 followed by str2. For example, concat key, comma board returns keyboard. Okay, that seems reasonable. Reversed str returns the reverse of the string. For example, reverse ABCD returns DCBA. It returns the string in opposite order. The characters are in reverse order. So which of the following code segments can be used to store noon in the string variable word? So I encourage you to pause the video, take a look at each of these, and see if you can come up with an answer. Ready to see the answer? Here we go. The answer is C. Well, let's take a look at what happened here. Word is ON. Now remember, our goal is to make word noon. It starts out with just ON, but now we're going to update it by concat, reverse word, and word. Well, let's see what reverse word does. Reverse word would take word which is ON and reverse the order, NO. So this first part is NO, and word is still ON. So when I concat NO and ON, I get noon. Let's take a look at these others. If word starts at NO, when I do reverse word, I get ON. So when I would concat, I would have ON and then NO. Oh no, not correct. If word starts at no and I reverse word, again, I'm going to get ON first, and now I'm going to get ON again. So I have on. Nice, but not working. If I start with ON, and I reverse it, I get NO, which is okay, but I'm reversing, so I get NO again. So no, not the answer. So our answer was C. Let's try another one. This time we have concat, and it looks pretty similar. Returns a string consisting of str1 followed by str2. We have the exact same explanation. Concat keyboard returns keyboard. But this one's different. Prefix str length. So this returns the first length characters of str. Or if str returns str if the length is greater than the number of characters in str. Ooh, that was even a little tongue-tied for me. However, when that happens, even when I'm reading, they always give us an example, so it's okay. If you're not quite sure what the words mean, look at the example. Often that will help you out. So prefix delivery 3 returns del because I want the first 3 characters of this string, del. But if I do prefix delivery 100, well, I don't have 100 characters in delivery, so it will just go ahead and give me the original string back delivery. All right, so the variable initials is to be assigned a string consisting of the first letter of the string first name, followed by the first letter of the string last name. Which of the following assigns the correct string to initials? I encourage you to pause the video and work these out. And when you're ready, I will have the answer for you. And the answer is A. So remember, we want the first letter of the first string, a first name, followed by the first letter of last name. So my name is Sandy Chaika. I would want SC. So concat, that's going to put the two things together. Prefix, first name one. So it's taking my first name and getting just one character. That works. And then it's taking the prefix with my last name and the first character. So that will get S and C, put them together with concat and give the initials. Just to be clear, B will not work because this will give us two letters. So it would give me SA, and in my case, CZ, because I have a crazy last name. So SACZ is not my initials. This is concating first and last name. So it's going to put Sandy Chaika and then get the prefix. So it's only going to return S. This will also concat first and last first. So Sandy Chaika, and then get the first two letters. So it's actually going to give me SA, and that's not my initials. Okay, I think you've done a little bit now of strings. Let's move on and try a different type of question. We're still going to be in procedures. In this case, we have a procedure called draw circle. So again, this is one that they're telling us about it. It's not on our reference sheet. The stuff on our reference sheet still holds true, but this is in addition to what's on our reference sheet. So draw circle takes three parameters: xpos, ypos, and rad. And it draws a circle on a coordinate grid with center xpos and ypos, so x position, y position, and radius rad. We want to use the draw circle procedure to draw the following figure on a coordinate plane. Let the value of the variable x be 2 and the value of variable y to be 2 and the value of r to be 1. Which of the following code segments can be used to draw this entire figure? So you've got quite a bit to look at. Pause the video and we'll take a look in a moment. So this might have taken you a little while to reason through, but the answer is B. Well, let's take a look. Remember we said x is 2 and y is 2. So we have 2, 2, and radius 1. So if I go to 2, 2, I can see it makes a circle of radius 1. So that was okay. Now I do draw circle 2, and 2 plus 3 is 5. So I go to 2, 5, and I still have a radius of 1. So 2, 5. Oh, this is looking good with the radius of 1. Excellent. Now this next line, 2 plus 3 is 5. So I go to 5, y is still 2, and r is 1. So when x is 5 and y is 2, that looks good. A radius of 1 is good. And then the last one, 2 plus 3 is 5. 2 plus 3 is 5. So I go to coordinate 5, 5. Nice, with the radius of 1. This part A, option A, wasn't going to work because they only added 2. So I would have been shifted down and shifted to the left. This other one didn't quite shift correctly. And on top of it, it changed the size of the radius, which was not good. It would have made circles that were too big. And this one definitely made circles that were too big. So it would have made circles of radius 4. All righty, let's move on. So a student wrote the following procedure to calculate the sum of integers from 1 to 5. We can see what this says. Sum starts at 0 and count starts at 1. We're going to repeat until count is greater than 5. So in other words, when count becomes 6. We're going to add sum and count and update sum. And we're going to add 1 to count. When this loop is over, we'll return sum. So this is going to work. This will add the numbers 1, 2, 3, 4, and 5 and give us the correct sum. But later, the student decides to modify the procedure to calculate the sum of the integers from 1 to max, which represents any positive integer greater than 1. So which changes should be made to the procedure to meet the student's goal? So you need to check each one of these. 1, Roman numeral 1, the procedure should take max as an input parameter. Roman numeral 2, the condition in the repeat until block should be changed to count is greater than max. Roman numeral 3, the condition in the repeat until should be changed to max is less than 5. So you want to see, is it only 1, only 2, 1 and 2, or 1 and 3? So think it through, pause the video, and I'll have your answer when you come back. The answer is C, 1 and 2. So if I don't know what max is, that means I need a parameter. So that's why we want 1. We want max to be an input parameter. So that would be up here, probably in a rectangle. And this way, whatever value they put in there, it would do the sum from 1 to max. So if I said sum of n's 3, it would add 1, 2, 3. If I said sum of n's 10, it would add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's not enough because I need to change this repeat until. So when I did count is greater than 5, that did the sum from 1 through 5 inclusive. I want 1 through max inclusive. So I'm going to want to change this to count is greater than max. So I do need to do Roman numeral 1 and 2. But 3 would undo what I just did because I changed the repeat until. So I don't want to do 3. When I do these questions, I try to go through each one. And if I think it's true or a possible answer, I circle it. And if I think no way, I put an X through it. And then I look at my options down here. Make sure you check all of them though. All right, so we have a student is developing a program that allows users to look up the definitions of words that appear in a book. Sounds nice. The student plans to perform a large number of searches through a dictionary containing words and their definitions. The student will use a procedure written by a computer scientist to quickly search the dictionary and knows that the procedure will return a definition if one is available. The student cannot modify the search procedure written by the computer scientist, but can call the procedure by supplying a word. Which of the following is a true statement about the student's use of the computer scientist search procedure? The student is changing the search procedure's internal abstractions. B, the student is modifying the search procedure to take definition as an argument and return the corresponding word. C, the student is reusing the computer science procedural abstraction by knowing what the procedure does without knowing how it does it. And D, the student is reusing the computer scientist procedural abstraction by using duplicate code each time a search needs to occur. Feel free to reread the question and answers, and we will go over this in just a moment. When you come back, the answer now is C. It specifically said in the stem here, the student cannot modify the search procedure. So changing the search procedure, modifying the search procedure, we were told they can't do that. So A and B cannot be true. The student can use it. They don't need to know what how the code does it. They don't need to even see that code. They're not duplicating the code. That kind of takes away the convenience of using something someone else did. So our answer is C. Let's try another one. The transportation department plans to build a new high-speed train route between two cities. The transportation department wants to implement a simulation of the train before any construction begins on this project. Which of the following statements is true about the use of a simulation for this project? A simulation cannot be used to test the train under varying weather conditions. B, implementing a simulation is likely to increase the overall cost associated with the project. C, other high speed train routes have been constructed in other locations, so a simulation is not needed. Or D, using a simulation may expose potential safety issues that can be corrected before construction begins. If you need to pause and reread, please do so. Come up with what you think the best answer is and come back for the real answer. Hopefully, they match. Our answer is D. Simulations help us kind of foresee potential issues before they happen. I know that the simulation is not in bad weather, but we can program in the variables that are associated with different weather conditions. That would be a good simulation. Um, Actually, a simulation often does not increase the cost because we can figure out the problems before they happen. So we're not having to take things apart after we already made them. And just because there's routes in other locations does not necessarily mean that all of their factors are going to be the same for the new route. Let's look at one more. A graphic artist uses a program to draw geometric shapes in a given pattern. The program uses an algorithm that draws the shapes based on input from the artist. The table shows the approximate number of steps the algorithm needs to draw different numbers of shapes. So when we need to do 4 shapes, it takes about 17 steps. For 5 shapes, about 24. For 6, about 35. For 7, about 50. Based on the values in the table, which of the following best characterizes the algorithm for drawing n shapes, where n is a very large number? So the algorithm runs in a reasonable amount of time because it will use n steps to draw n shapes. The algorithm runs in a reasonable amount of time because it will use n squared steps to draw n shapes. The algorithm runs in an unreasonable amount of time because it will use n steps to draw n shapes. And the algorithm runs in an unreasonable amount of time because it will use n squared steps to draw n shapes. Take a look at the table, pause the video, and see what you think your answer might be. The answer is B. The algorithm runs in a reasonable amount of time because it uses n squared steps to draw n shapes. So you might say, well, 4 squared is 16, but that's pretty close. 5 squared is 25, that's real close too. 6 squared is 36. 7 squared is 49. Remember, these are approximates, and that's all we need. So it wasn't 1 to 1. So it wasn't 4 and 4, or 5 and 5, or something real close. But the reality is, whether it took n or n squared, either way, that's still considered a reasonable amount of time. Got another one for you. A student wants to determine whether a certain problem is undecidable. Which of the following will demonstrate that the problem is undecidable? Show that for one instance of the problem, an algorithm can be written that is always capable of providing a correct yes or no answer. B, show that for one instance of the problem, no algorithm can be written that is capable of providing a correct yes or no answer. C, show that for one instance of the problem, a heuristic is needed to write an algorithm that is capable of providing a correct yes or no. And D, show that for one instance of the problem, an algorithm that runs in unreasonable time can be written that is capable of providing a correct yes or no answer. A lot of words there, so feel free to pause, read them through, come up with your best answer, and I'll come back and meet you with the answer. The answer is B. Is if we even find one instance where there's no algorithm that can provide a correct yes or no answer, that is what makes it undecidable. I don't need all of them to not have a way of doing it, but if even there's one situation where there's no algorithm at all that is capable of providing a yes or no answer, then it's undecidable. All right. You have done fantastic. Let's talk just one more time about our Create PT tip of the day. Written responses, some general information. Make sure you answer each part of the question. You don't want to leave anything blank and make sure you're answering what the question asks for. Code segments should be images, and these do not count towards your total words. So you're going to upload images for your code segments and the parts that ask you to show code that demonstrates specific things. Part D asks about 2 calls to my procedure. Do I need that in my code? Well, you don't need those 2 calls. So you can put in examples of calls to your procedure with actual values for your parameters. Those values might not ever be in your program. You're just showing how that procedure would work with 2 different values that would execute different parts of the code in the procedure. These exact calls do not need to be in your code at all, but you should have at least one call to your procedure somewhere in your code. Don't forget, we have this link here, and that will take you to a Google folder, which has a document that covers some of the areas that you can go to get more information about the create performance task. So what should we take away? Algorithm and program questions will be given in pseudocode. Make sure you're familiar with that exam reference sheet. We want to be able to interpret code with procedures that have or do not have return statements, and understand the benefits and limitations of simulations and heuristics. Before we leave today, I want to take a moment to talk about the exam format. Just to remind you, all questions are multiple choice of some type. The first 57 will all be single select, only one answer, one answer for the first 57. And actually, the next 5 will also be single select, but those will be about the reading passage. So in total, your first 62 are all single select, only choose one answer. Then after the 5 reading passage is where you'll get 8 more questions that are multi-select. Multi-select are select 2. You're never going to have 3 or 4. It's only select 2. Remember, you can go back to look at previous questions. So when you're going through the test, if you get stuck or something seems to slow you down, feel free to circle that, go back later and look at it maybe after you finish the rest of the questions, and you can be a little more calm. Some general reminders and tips before the exam. Try to study every day just a little bit. I'm not talking about an hour, 2 hours, 15 minutes, 20 minutes max. Do a little bit every day and it will add up. Maybe you'll get some time in your class to do that, but no matter what, make sure you're at least looking at one thing, even if it's just vocabulary. Speaking of vocabulary, maybe make some flashcards with all the vocabulary. It's a nice way to review. Don't forget to review the exam reference sheet again. And ask your teacher or search online for more practice from AP Classroom or from other endorsed providers. Please make sure you get plenty of rest prior to the exam day. Being tired does not lead to good answering of questions. We really want to make sure you're rested. On the day of the exam, make sure that you eat a breakfast or a snack or a light lunch, and make sure you drink water. You want to be hydrated before the exam. Be ready to work for 2 hours on the exam. You get 2 full hours to answer the 70 questions. There is no break during that time. Remember to bring pencils. You're going to fill in the answer sheet with the pencil, but you also want a pen because there is a part where you either sign or put your initials in pen. Don't forget, read each question carefully. Remember, some of these get a little wordy, but that doesn't mean you can't answer them. Take your time, underline, circle, do whatever you need to really be able to understand the questions carefully and completely. One more thing. Good luck. You've got this. I know you're going to do awesome. You've been working hard. Keep it up. You've got a little bit of time yet before the exam, and I wish you all the best. No matter what, I hope you had some fun learning some computer science, and I hope you'll learn a little more and keep studying it. It's a great area, and it's affecting everyone in our lives in all different ways. So I hope that you got a lot out of this class and the reviews, and that maybe you'll go on to do even just a little bit more, if not a lot more, with computer science. Thank you for attending the review. I appreciate you being here, and I wish you nothing but the best. Good luck, and thanks for coming. Now go out and have some fun with CS.